there are only two students who are here? Hmm. Okay, hi everyone. Today we be continuing from the last week's chapter, and we start the screen sharing. Okay, so the first part we are going to learn is the identity matrix. Okay, so what is an identity matrix? Identity matrix. Okay, first, because I see the textbook from there, so I just explain from the example. Okay, identity matrix. Okay, identity matrix we must know, and identity matrix it always must the order for the order of identity matrix. It must the row and the column it must be the same. For example, it can be 3 times 3, or here 4 times 4, 5 times 5. And the pattern to form the identity matrix is you can form a 1 in a sequence like that. In a sequence down like that. 1, 2, 3. Yeah, I can form the 1 in a sequence like that. Okay, for example, I do one more. 3 times 3 matrix identity. The identity matrix for a 3 times 3 matrix, it would be 1, 0, 0. 0, 1, 0. 0, 0, 1. Okay, so you can see the first just the sequence is like that lah. Okay, for the first row, the 1 must be at the first position. The second row, 1 must be at the second position, and continue. And this is what the identity matrix is. Okay. Okay, if you look at the self-practice here, which of the following matrix are identity matrix? If it's not identity matrix, give your reason. Okay, so this one is not an identity matrix because identity matrix, the 1 must be at the first position like that. And 1 times 1, so 1 row, they shouldn't be any identity matrix. 1 row can, yeah, sorry, 1 row can, but normally, yeah, and sorry, 1 row you can put identity matrix, but the 1 must be at the first position always. The 1 must be at the first position. If a 1 times 2 matrix should be a 1 times 2 matrix. If it's the identity matrix, then it's 1, 0. So this one, the 1 is not in the first position. For the second one, it's no. Because if it's identity matrix, it should be like that. 0, 1. The 1 is not the sequence that go down like that. This one also no. This one, it should be down there 0, 0, 1. And then here should be 1, 0, 0. So the 1 can go down like that. Can form a row down. Like this one, yes. This one, yes. This one, no also, because the 1 must be at the first position up there. And the second part also don't have a 1. So these are identity matrices, which I think it is a, okay. It's okay. So like number 2, it is given that the matrix C, negative 1, 3, 2, and 5, and matrix D is 1, 0, and 0, 1. Show that the matrix D is an identity matrix. Okay, how to show an identity matrix? Okay, we look at the sample above. I think we okay. Matrix B in the form of these and these when multiplied with matrix A. will result in the matrix A. That is A times B equals to B times A and equals to A. So any matrix that times with an identity matrix, you get the same. You get the same matrix as the original one. Okay, for example, like this one, a 2 times 2 matrix times with a 2 times 2 matrix. So we know that this is always a 2 times 2 matrix. Okay, we use C times D first. Okay, C times D, you will get -1, 3, 2, 5, okay, times with 1, 0, and 0, 1. Okay, let me calculate. Let's see what is the answer. Just 1 minute. Okay, so if we do it, we'll get the same as this. Okay, 2 times 2 matrix. Okay, I will write the working for you. Just so on, I am writing the working. Okay, so first we use -1 times with negative times with the 1 here. The 1 times with the 1 here. Yeah. And then the second is the -1. Sorry, not -1, the 3. And the -1 times with on. Yeah. The 3 times with the actually this one it times with this one times this one plus this one times this one, and then 3, 0, you should get -1. And then you plus your, okay, 3 times 1. Actually, 3 times 0. Okay, 3 times 0 plus times 3 times 1 plus 3 times 1. And then the down part here, it should be 2 times 1 plus 5, 0. Yeah. And then why there is no plus here? Okay, there is no plus here. And then the last part, it's 50 plus 5 times 1. So you get the same. You get the same. You will still get the same. Okay, so how to prove an identity matrix? You times a matrix with an identity matrix, you will get the same as the original one. Okay, it's proven that this is an identity matrix. Actually, when you see like that, it's an identity matrix because one can form in a row down like this. Okay, after that, we're going to learn about inverse matrix. Okay, what is an inverse matrix? Okay, okay, when like this one, A times B is equals to B times A, then equals to identity matrix. If the multiplication of matrix A and B produce an identity matrix I, identity matrix use a single I, then matrix B is the inverse matrix of A, or vice versa. Okay, for example, now this one is A times B produce an identity matrix. You get 1, 0, and 0, 1. Okay. And so B is the inverse matrix of A. So this one is the inverse matrix of this one. Or vice versa, this one is the inverse matrix of the first one. The second one is the inverse matrix of the first part. Okay. Okay, the multiplication of matrix A and inverse matrix of A. If you times A with the inverse matrix of A, then they result with an identity matrix. Yeah. So if you times the matrix with the identity matrix of another one, they will come out an identity matrix. Okay, like example 22, determine whether the following matrix is the inverse matrix of 4172. Explain the answer. Okay, this one, whether it's the inverse matrix of this one. So when we times it, you can just use a calculator, you get this answer. So this is not an identity matrix. If an identity matrix, it should be in this form. So it's not an identity matrix because it comes out like that. This 4, 1, negative 7, and 2 is not the inverse matrix of this because the product is not an identity matrix. How about the second one? B is B, 2, negative 1, negative 7, and 4 is the inverse matrix of the first part of 4, 1, 7, and 2. So when you times it, yes, it's an inverse matrix because it comes out an identity matrix. Okay, they ask you determine whether the following matrices are the inverse matrices of one another. Okay, we just use both of these times lah. We do A and D. They just imagine we times it. Okay, see what we get. 5, 4, 3, 2. The first one, I think, is a yes. Okay, the first one is no, sorry. So you get this negative. Why it's a bit on? Recalculate. Okay, so when I calculate, yeah, you get negative 2, 0, 0, and negative 2. It's not a 1, so it's not an inverse matrix of one another. So let us try this part. D. Later you see a relation, how you form a inverse matrix, which I think most of you have learned. Yeah, you get an identity matrix. 1, 0, and 0, 1. So you can see if a matrix, we just put A, B, C, D in a. So you see the inverse matrix, it will become. Okay. So CA yeah. Okay. So A yeah, so it's negative B. Okay, negative C, and D is the same. So this is the relation of identity matrix. Yeah. Okay. Okay, how to determine the identity matrix of 2 times 2 matrix? It's the one I've mentioned. The result of the scalar phenomenon. Okay, given that A is this, the inverse matrix can be defined as, just now, actually I didn't really complete. It's like A, D, negative BC, and 1 over AD, this part minus this part, and times with this part, the one I show you just now, then we will get, with the condition this is not 0, If you have 0, then you get 0 lah, the whole thing. Okay, for each of the following matrices, determine whether it's an inverse matrix exists. So for you to determine the inverse matrices, we need to 1 over AB. Okay, minus, sorry, AD, not AB. AD minus BC. Actually, you can just use 1 over, or you can just use AD minus BC. You see whether it's 0 or not. If it's 0, this one you also get 0. Sorry, you get infinity. 1 divided by 0, you get infinity. So yeah, you can also use AD minus BC. You see whether it is 0 or not. If it's 0, you will get infinity. You cannot calculate, so it does not exist. Like the B is an inverse matrix, because this one, AD minus BC, you get 2. So you get 1 over 2 times with the 1. AB. Yeah, you get something like that. Okay. So get yeah, AB negative B negative C. Sorry, just now I wrote something wrong, I think. Yeah, it is D negative B negative C and A. Okay. AB negative B negative C. But I think it's okay. I think just now I wrote B. Okay, okay, example 25, given that matrix D is this, calculate the value of M if it does not have an inverse matrix. Okay, if it does not have an inverse matrix, AD minus BC equals to 0. So you just use your linear equation, you get M, it's 3. So if the inverse matrix of that equals to this. Okay, so the inverse matrix will get this. So actually there are few methods for you. You can use this method, because we know that D times with the inverse matrix, you get an identity matrix. This is one method. Or you can use your 1 over AD minus BC times with AD negative B negative C. Yeah, and you get your M. For example, AD, you get negative 2M BC minus minus, you got plus 6. Then you just your A is M, your D is -2, negative B you get 6, negative C you get 1. Yeah, so actually you can just do this way. Okay, so then I just write on top, you get -1, -2m plus 6. Okay, equals to -1. So you get -1 equals to 2m minus 6. You bring the 2m plus 6 up. -1, 2m, you will get -1 plus 6. Okay, you get 5. See, 5 over 2. Okay, m is 2. Then it's something wrong with my working. Okay, 1 over AD minus BC. Okay, you get AD negative B negative C. Or on. Sorry, it's 2 or not. Hey, what am I doing? And you know what I did wrong just now? We use -2. Okay, you get 2m plus 6 equals to -1. Just now at top I write -1, it should be -2. Then you get -2, you get 2m minus 6. Okay. So 2m you get equals to 4, and you get equals to 2. Yeah, so m you get 2 also. You can use either one of the method to solve. Okay. This one times A has an inverse matrix, and A has an order of 2 times 2. So we know that they produce an identity matrix. So we know that the A is an inverse matrix of this one. So we just use the inverse matrix method. We will get the answer. Okay. We do some of the questions. Oh, okay. For each of the following, determine whether inverse matrix exists. Yes, calculate the inverse matrix. So I just do one example from here. I just do A. So we just use AD minus BC. See what is the answer. Example AD is 6 times 1, BC is 0. 0 times 0 is 0. Okay, so you get 6 minus 0. So you get 6. So A, there is an inverse matrix because AD minus BC is not 0. Okay, calculate the inverse matrix of the following matrices. Okay, I just do C from here. So we just use 1 over AD minus BC. Okay, so you will get your okay, the negative, okay. Yeah, BA, negative B and C, and negative C. Like your A is 4, your D is 2. Negative B, you get 2. Negative C, you get 3. So you get this. So you get 1 over 4 times 2 is 8 minus 6. Okay. 2, 2, 3, and 4. Okay. 8 minus 6 is 2. Half times with this one. And this one is 2. I write properly, it looks like 3. Okay, which you will get I just write here lah. You will get 1, 1, 3 over 2, and 2. Okay, so this is the inverse matrix. Okay, it is given that I do one more. I will do one more. I do question 3. Okay, it is given that matrix G equals to 2, 1, 3, and P. Okay, calculate G if it does not have an inverse matrix. So AD minus BC, you will get 0. So 2P minus BC, which is 3, will get 0. So 2P equals to 3. So P is 3 over 2. Okay. This is 0. AD minus BC, you get 0 for an inverse matrix. If G negative 1 is this, as I said, there are two methods. If you use the one that times you get the identity matrix also can, or you use that method also can. For example, I use 1 over AD minus BC. AD minus BC minus 3 times with the one negative AD negative B negative C. So you can use this method. P you move on top, negative B, negative C, and the A. So you get this 4 over 5 negative 1 over 5, negative 3 over 5, 2 over 5. Okay, then you get p over 2p minus 3. Or you can use any one. You can use any one equals to 4 over 5. You can use anywhere. You can use anywhere. So p is equals to 4 over 5 times with 2p minus 3. Although this is a bit long, then you get 8 over 5p minus 12 over 5. So we will get we get negative 3 over 5 p. Equals to negative 12 over 5. So 5 and 5 we can cut. So negative 3p is equals to negative 12. So p we get 4. Yeah, we get 4. So done with question 3. So is it okay for you all? No questions. Okay, then we proceed to solve simultaneous equation. Then I will pass the time to Prina.
Hi everyone, thank you Kaisen. So my name is Pravina and I will be teaching you about solving simultaneous equations through by using metrics. But for now, I think I will just give you all a 5 minutes break so you all can come back at 9:25 just to refresh yourselves so that you can absorb this subtopic better later. Okay. All right, so the 5 minutes break is up. So now I will be sharing my screen. Okay, so this subtopic is relatively not to say easy, but then once you get the concept down, it should be easy to understand. So here you can see it's solving simultaneous linear equations. I assume you all already know how to solve simultaneous linear equations, with the usual substitution method and all that. But now you will learn how to do it using matrices as well. All right, so if you can see here, two simultaneous linear equations can be written in the matrix equation. So to do that, you can see the examples here. Ax plus by equals to E, and cx plus dy equals to f. So when you write them down in the matrix form, you just copy down the equations like so. So you take the, just imagine you're writing down the equation. So here you got A, and then B, and then you put E over here. And then you just apply the same concept to the second equation. Usually I like to write it down like this just so that I won't get confused. So then once you already write it down like that, the equation, you sort of already know which numbers to place and where. So once you have that, then you can write down the x and the y. Yeah, so that's how you get this one. All right. So here you can see an example. Write the following simultaneous linear equations in the matrix form. So you have your equation here, and you can see it's not really in the standard format yet, because usually when you want to write your equations in the matrix form, usually want it to be in the form like above, where you have it as x plus y equals to your value. So here you can see that the equation, it's written y minus x, and then you have your value here. And then at the end of the equation, you have 0. So to solve this and to make it easier for you, you can write it down like so. As you can see here, negative 6x, we just bring it down, plus y. And then the 19, we bring it to the other side. So here it's negative 19. So here it will be positive 19. And we apply the same concept to the second equation. 3x, we bring it down here because it's still on the same side. And then 2y, we plus because it's also on the same side. And then this positive 22, we want to bring it to the other side. So when we bring it to the other side, we put it as negative 22. So once you have this equation, you can use the format above, and you can write it down negative 6 plus y. So because y, when you don't have a digit in front of your unknown, then you already know that the value is 1. So you write down 1 over here, equals to 19. And then the second equation, 3 plus 2 equals to negative 22. And then if we follow the way I wrote it before, you just fill in the brackets and you fill in the xy unknown here. So that's how you write down the equation. All right, so here's just the general formula for how to wait, yeah. Right, so here's just the general formula on how to find the matrix in the equation using the inverse matrix. So this will be the base of how you will solve your simultaneous equations through matrix later. All right. So here you can see if AX equals to B, then X equals to A inverse matrix B. So here you can see it says matrix equations in this form can be solved for the unknowns X and Y as follows. So let's say this is matrix A. And so if you want to get rid of matrix A on this side, you usually in simultaneous equations, it's relatively the same concept where if you want to remove something from one side, you have to do the opposite operation to get it to the other side. Like let's say y minus 3 equals 0. So then to move 3 to the other side, you have to do y minus 3, and then you plus 3. And then because it has to be equal, you have to plus 3 on the other side as well. So you can see you're using different operations. You're using different operations. So it's the same concept for times and divide. So because here we have the matrix, to remove the matrix A from the left side, you have to times it with the inverse. So if this is your matrix A, then the inverse of matrix A will be like the formula just now explained, 1 over AD minus BC times this arrangement of the previous matrix. Okay, so as you can see here, we have to multiply both sides of the equation by inverse of matrix A. So this is the matrix A, and we multiply with the inverse. And here we have the inverse as well. So because this is the inverse, we just substitute this part in. So you can see here. All right, because when you times matrix A with the inverse, you will usually get this matrix. And so when you times this matrix, because I equals to this one over here, when you times this matrix with X and Y, you'll still get X and Y. So that's why it looks like suddenly the I is missing, when in reality, you just times it in. So then you can still see that this inverse of matrix A, you still have to times with the value that you put in previously in the equation, which is E and F over here. So then you just sub in the formula for inverse of matrix A, and you times it with the value that you already have there. All right, so here we have a few example questions. So here it says, solve the following simultaneous equations by using the matrix method. All right, so we'll just go through this question. All right, so we have the equations 2x equals to 5 minus 3y and 7x equals to 1 minus 5y. So like I said earlier, we had an example as well where the equations were not written in the quote unquote standard form. So you can sort of fix that by writing it down in an x plus y equals to your value format. So that's what they did over here. So you can see here 2x, it's there. And then because negative 3y, it's on the right side, we want to move it to the left side. You change the value, so it's positive 3y. And then the 5 stays the same because it's still on the right hand side. And the same concept goes for 7x here. And then the negative 5y, because we're moving it from the right hand side to the left hand side, you do positive 5y equals to 1. So in any question involving solving simultaneous equations, simultaneous linear equations using matrix, you should usually just write your equation down like this first, just so that it will be easier for you. All right, so over here, you can see it's written down like the concept earlier. So you have 2 plus 3, and then you write on the 5 here. And then you have the 7, 5, and 1. And then you just put in the brackets and the x and y. And so once you do that, then you sort of have to apply the inverse matrix. All right. So once you do that, this will be your matrix A, just as an example. So you can see here, let A be this matrix. So the inverse of this will be this formula that you have to follow. So now, what's happening is that this formula is happening over here. And once you start applying this formula in your equation, then this one will have become the matrix 1, 0, 0, 1. Yeah. So you apply this one here, and then by right, your equations should start to look like this. All right. So then you can see the AD minus BC. So because your A and D, it's 5 and 2. So 5 times 2, you get 10. And your BC, it's -3 and -7. So -3 and -7, when you times it, you get 21. So here is your AD minus BC. And then you will get -1/11. So then you just copy down everything else. So then, like I said earlier, you should, by right, have written down this equation. So usually when you're answering your questions, I wouldn't recommend for you to just write it down like this, or at least leave a partition so that nothing gets left out, and then you don't suddenly put in the matrix, this matrix or this XY. So I just recommend you sort of copy everything down and then solve it like one by one. Yeah. Okay. So after that, once you have this one again, when you times it will usually be like this and like this, and then it will go that way. So as you can see here, the 5 times 5, and then you plus with the -3 times 1. So then usually your values, it will only end up as like this. And then here you can see again -7 times 5 plus 2 times 1. You always want to plus the multiplication you get from this matrix right here. All right. So once you solve that, 5 times 5, you get 25. And then -3 times 1, you get -3. And because it's plus here, and negative positive, you get negative. So that's why it's 25 minus 3. And then here, -7 times 5, you get -35. Plus 2 times 1, you get 2. So when you solve it, 25 minus 3, you get 22. And -35 plus 2, you'll get -33. So once you get this, then you just times it in. So it will go, it goes like -1/11 times 22 and -1/11 times -33. So when you times that, you will get -2 and 3. So like I said, you should usually copy everything down. So then you would probably get something like, it's quite repetitive, but it helps you avoid making mistakes. So you would have to copy this X and Y matrix up till here. So then when you get something like this, X and Y, then you can see that X is in line with -2 and Y is in line with 3. So that's how you get the value x equals to -2 and y equals to 3. If there's anything that any of you are unclear on, you can just say so in the chat box. All right, so here we have another question. This one is more to solving a word problem using inverse matrix, and usually during the exams or during any question papers, they will usually clarify that they want you to solve the question using matrix. So you can see here, wait. All right, so you can see here, you can read the question. A hawker sells laksa and karimi. The number of bowls of food sold during a particular day are shown in the table. The income received from the sale of laksa and karimi on that day was 291 and 130 ringgit respectively. So for laksa, the income received was 291 ringgit. So this would be 291, the total. And for karimi, the total would be 130 ringgit. So they already clarified here, if the cost of a small bowl of either food is X ringgit, so a small bowl, we already know it's X ringgit. And the cost of a large bowl of either food is Y ringgit. So they already gave you the unknowns. They asked you to find the values of X and Y. So they never explicitly stated it in this question you needed to solve using matrix. But usually during exams, they will tell you, they will make it clear that you need to use matrix. So yeah. All right. So the equation we're going to use is, all right, so we already know the small bowl is X ringgit and the large bowl is Y ringgit. And we know the total is 291 for laksa and 130 for karimi. So to solve this, we write down the equation. So if you can see here, 42 small bowls plus 36 large bowls. Because we don't know the exact value, you'll get 291 ringgit. So this is what they wrote down over here. And then to simplify, you can break it down to 14x plus 12y equals to 97. And to get this, you just divide all of the values here by 3. Yeah. So then following that concept, we write down the second equation as 20x plus 15y equals to 130. Here you can see the 20x plus 15y equals to 130. So that's where they got the equation from. Then to simplify, once again, you can divide by 5. So that's how you get the simplified equations. And usually when you simplify it, it will usually make the numbers, the values you get at the end smaller so that it will be easier for you. All right, so once you get the equation, you just write it down again, like so. 14, 12, 97, you can see your 14, 12, 97, and then 4, 3, and 26, so 4, 3, and 26. And from there, you can start to fill in the blanks, this X, Y, the brackets, and so on. So once you do this, again, you can think of this as a matrix A. So once you get that, here what happens is that you times in the inverse. So that's why you don't see this matrix down here anymore. So once you times in the inverse, you'll get the 1001, and that will leave you with xy, because when you times it in, you'll still get xy. So here you have the 1 over AD minus BC formula, and you just switch it according to this concept, right? So here, to get the this value over here, you have to take 14 times 3 minus 12 yeah, you have to take 14 times 3 minus wait, yeah, give me a moment. Right, so I think there's a bit of an error here. So all right, so here we just continue from here. So we just copy down the xy equals to 1 over AD. So our AD is 14 times 3. Minus our BC, which should be 12 times 4. And then you have to follow this D negative B negative C A formula. So then it would be the A and D, you just switch the places. And then the B and C, you just times -1. And then from there, you times it with the value here, 97 and 26, which you can see from over here. All right. So xy equals to 1 over 14 times 3, you would get 42, minus 12 times 4, you would get 48. Yeah. So then here, you can see they already times it in immediately. So again, following the same concept, 3 times 97, negative 12 times 26, negative 4 times 97, 14 times 26. So you can see that's sort of the working they did down there. So if we copy that down, then 3 times 97, you would get 291. And then negative 12 times 26, you would get negative 312. Negative 4 times 97, you would get negative 388. And then 14 times 26, you would get 364. All right, so if we were to simplify that, 291 minus 312, you would get negative 21. And in here, negative 388 minus plus 364, you would get negative 24. So here we also got 1 equals to negative 6, negative 1 over 6, sorry, from the 1 over 42 minus 48. So you can see here, this is what you should get. And then you times in the negative 1 over 6 with the negative 21 and negative 24. So negative 1 over 6 times negative 21, you'll get 3.5. And negative 1 over 6 times negative 24, you'll get 4. So therefore, you'll get your x would be equals to 3.5, and your y would be 4. So that's how you would solve linear equations using metrics. I think we still have time to go over maybe just one or two questions before we end this session. So if you look over here, all right. All right, so let me just look for a question. Okay, so overall, the questions don't really differ. So I think we'll just start with 1. So we can skip ahead to 1b. So the question asks you to write the following simultaneous linear equations as a matrix equation. So they give you a set unknown, which is u and v, and they already gave you the equations in the like we established earlier, like a not so standard form. So your first step would be to right. So if you can just look at the equation. So your first step would be to rearrange the. It would be to wait, yeah. It would be to rearrange the equation. So to do that, you take. Oh, I'm sorry, I said it wasn't in the standard form, but the equation is already sort of arranged for you. So from there, you can just write it down like earlier. So 3, -1, 9, 5, -2, 13, and then just fill in the rest. Right. So then from there, your variables will be here, and then you just times in the inverse. So, all right. So what happens here is basically this part is the 1 over AD minus BC. And then here you will have your, you sort of have to flip it according to the, switching places A and D, and you times B and C with -1. So here you will put your -2, then here you have 3, and then here you have 1 and -5. So sorry if the writing isn't really that clear, but basically this is what happens. Let me rewrite. All right. So your 1 over AD minus BC, you take that from over here. Right. So your AD is 3 and 2. So 3 times 2, you would get 6. And then minus your BC is -1 and 5. So when you times -1 and 5, you'll get -5. But because of the negative here, you'll get wait, yeah, give me a moment. All right, so wait, yeah. I think there's sort of an okay. I didn't see the negative. Right. So here, basically, right here you have -2 and 3 and -1 and 5. So your 1 over AD minus BC, -2 times 3, it's -6. And then you minus the -1 times 5, you'll get -5. Right. So your 1 over AD minus BC, you should get -6 plus 5. And from there, you will get 1 over -1, which will be equals to -1. So then that's how you get this negative 1 over here. And then as for this negative 2, 1, negative 5, 3 here, basically what happens is that the 3 and the negative 2, you just switch places. So you can see the negative 2 and 3 here. And the negative 1 and 5, you times it negative 1. So negative 1 times negative 1, you'll get 1. And 5 times negative 1, you'll get negative 5. So, so this is basically what happens. And usually it will be easier for you to just, show the working. And don't take shortcuts like this unless you're really confident. But even so, I think it's best to, just not skip anything. Right, so this is what happens over here. So then continuing on. Right, so negative 2 times 9 plus 1 times 13. So here you can see negative 2 times 9, you'll get negative 18 plus 1 times 13, you'll get 13. And then here, negative 5 times 9, you'll get negative 45. Plus 3 times 13, you'll get 39. So negative 18 plus 13, you'll get negative 5. And negative 45 plus 39, you'll get negative 6. So once you already get this, you have to times it in with the negative 1 over here. So to this, you just times it in, together. So negative 1 times negative 5, you'll get 5. And negative 1 times negative 6, you'll get 6. So as you can see here, we've copied down the UV matrix. So you can see that U lines up with 5 and V lines up with 6. So you can conclude that U equals to 5 and V equals to 6. And that's how you solve that question. So I think we can do one more question before we end the session. So we can move on to number 2. Right. So again, you can see here, they've already arranged the equation for you. So 2u minus 5v equals to negative 15, u plus 3v equals to negative 2. So again, you copy down the equation like so, 2, negative 5, negative 15. So 2, negative 5, negative 15. And here you have u, so that will be equals to 1, 1, 3, and negative 2. And then you just fill in the blanks after that. Right, so after that, so once you do that, again, what happens here is the 1 over AD minus BC. So this is your A and D. When you times it, 3 times 2, you'll get 6. Minus your BC is negative 5 times 1 over here. So negative 5 times 1, you'll get negative 5. Right. So you'll get 6 plus 5. So once you get that, you'll get 1 over 11. So that's how you get this 1 over 11. And again, this one over here, this matrix, it looks a little bit different from this one because you have to substitute with the, as you can see here, 3 and 2, your A and D, they've switched places. And then your B and C, which is your 1 and negative 5, you have to times with negative 1. So negative 5 times negative 1, you'll get 5. And 1 times negative 1, you'll get negative 1. So that's how you get both of these components, which will be your inverse matrix of this one. The formula to find the inverse matrix. All right. So once you get that, then you have to times in these two matrices. So 3 times negative 15, 5 times negative 2, as you can see over here. So 3 times negative 15, you'll get negative 45. Plus 5 times negative 2, you'll get negative 10. And then here you have -1 times -15, you'll get 15. And 2 times -2, you'll get -4. So -15 plus -10, I'm sorry, 3 times -15, you get -45 plus -10. So it will be -45 minus 10. You'll get -55. And here you have 15 minus 4. You'll get 11. So once you simplify this matrix, you times it in with the 1/11. So 1/11 times -55, you'll get -5. And 1/11 times 11, you'll get 1. So as you can see, U lines up with -5 and V lines up with 1. So your U will be equals to -5 and your V will be equals to 1. So roughly that's it for solving simultaneous equations through matrix. So I think that will be all for this session today. So thank you for coming to the class, and you all can leave the room, the meeting now.